It's so great to be here. I'm coming to you from San Francisco. It's still morning here, and so I have a full day ahead. But I know for in the UK, we're getting close, hopefully, to bedtime. So of course, we start to think about kind of how can we get our best rest. Sleep is a biological imperative, right? It's something that all species that we've studied do something that looks like sleep, at least rest. And so we know that it's so critical to survival that it's kind of been conserved across that time. But also, we know from kind of experimental models that if we deprive an organism of sleep or rest indefinitely, they don't survive. So it turns out that you can survive longer without food and water than you can without sleep. And so it really kind of underscores how critical sleep is for survival, for our health, and for our well-being. And so, sleep is a beautiful, magical thing. And it's done in kind of the cutest of fashions by kind of animals out in the wild. Animals, a lot of them have kind of evolved to sleep in some precarious places, right? So we have the koala sleeping while kind of holding onto a tree to ensure that it isn't gobbled up by predators. Dolphins have semi-hemispheric sleep, where only half of their brain sleeps at a time, so that they can still breathe while they're sleeping, right? Because they have to kind of come up out of the water. These kind of really amazing mechanisms have evolved over time. But also just sleep is, pretty adorable, right? You can kind of feel that warm and coziness in these animals. And so, we know that sleep is so fundamental to so much of what makes us human. But though we know it's so critical for our health, our well-being, we know what it feels like when we don't have it. We're often kind of laying awake in the middle of the night, whether when we go to sleep, try to go to sleep, or when we wake up in the middle of the night, and our brain is often kind of filling that space. And, I don't know about you, but I would say that in the middle of the night, it's not like our brain is, we're focusing on all the best things that's happened to us, right? We're not thinking about kind of our best experiences. It's often filled with kind of that negative, ruminative thinking, that worrying about the fact that you're not sleeping and what that means for the next day. And that obviously can undermine our ability to get that important restorative rest. The good news is there are things that we can do about it. And I'm going to talk about those today as kind of strategies to get yourself back on track, because sleep is something that I think no one ever wonders how it works until it stops working. And when it stops working, people become very hyper-focused on how to get it back on track, right? But sleep isn't something that we make happen. Sleep is something that happens to us, kind of washes over us. But, as humans and kind of as doers, we often kind of do things to try to get sleep kind of back on track in that way, usually kind of in an anxious, distressed, kind of chasing sleep kind of experience. But that actually undermines how sleep works. And so I'll talk a little bit about that today. But first, a couple kind of basic pieces about sleep, some basic science. Sleep is not kind of this on-off switch, right? It's not that we kind of close our eyes and our brain kind of just goes into kind of rest mode, and then we wake up and it's back and we're kind of ready to take on the day. Sleep is very dynamic. And so, it actually follows cycles across the night, right? Typically in like 90-minute cycles, though that's kind of the best kind of usual kind of way in which people bin it. It can be less or more depending, but you can see here, this is what's called a hypnogram, and a hypnogram kind of basically charts kind of the stages of sleep in which a person is in throughout the night. So you can see on the bottom of the graph here is kind of time. And so this is across the night. And then on the y-axis, kind of the side here, are the stages in which people sleep. And so there are 3 stages within what's called non-REM sleep, or non-rapid eye movement sleep, going from kind of lightest to deepest. So stage 1, 2, and 3. Stage 3, or also known as N3, is where we get that deep restorative slow wave sleep. But the other stages are also really critical. And then on top of that, we also have what's called rapid eye movement sleep, or REM sleep. And that is, where dreaming typically occurs, but also seems to be an important type of sleep for things like emotional learning, emotional memory, all of the different stages. We're still trying to kind of chip away at what's going on in the brain during this time. But the point is that it's very dynamic, and it changes over that period of time. I also want to point out that it's not the same proportion of stages of sleep throughout the night. So you can see here in the first half of the night, there's much more of this bottom level, this N3, this stage 3 part. So kind of our slow wave sleep is disproportionately experienced in the first half of the night, while the second half of the night has more and more of this REM sleep. And so when people remember their dreams, it's often because they wake up kind of in the early morning hours before they're going to get up in the morning. And it's just a higher percentage that they're in this REM sleeps. And so it's more likely that they're going to remember their dreams because they're going to be coming out of one. But sleep is also regulated. And this is actually a really critical piece. And it underscores the importance of that we have these biological levers that really drive how our sleep works. And so it actually serves as a important way to try to regulate it, like things that we can push on to try to get our sleep back in an important kind of regulated manner. So the 2 principles that regulate our sleep, and they're not, they're certainly not, don't have the greatest names. It's process S and process C. Process C is refers to our circadian rhythm. And so this is our internal clock that, works on a little bit more than a 24-hour cycle. And I like to think of it, at least in this graph, and if you look at the C curve here, as an alerting signal. So as we're awake, as we get it throughout the day, our alertness is high, and then it dips into the evening. And of course, it's entrained by largely by kind of behaviors in our environment, but especially sunlight. And so as it gets dark, our pineal gland in our brain begins to make melatonin, and we get sleepy in that way. But see, that dip is really important in our alertness, and that's kind of an internal clock. The S curve is what's called our homeostatic sleep drive. And so this is basically a simple principle that we get sleepier the longer we're awake, right? So we can only be alert and awake for a certain period of time, and it builds up across the day. And we'll talk about this a little bit later, but I like to think of it as a balloon, where we wake up in the morning, our balloon is flat, and then as we go throughout the day, we use energy. It builds up and builds up and builds up, our sleepiness balloon. And then when it gets to kind of an optimal amount, you feel those sleepiness cues and you go to sleep. And so when our sleep drive, our process S and our process C are well aligned, you can see that, someone, their S curve is really high, their alerting signals are low, and then they can get that amount of sleep. Now, those can often be misaligned, right? So a good example is when you travel through time zones, your circadian rhythm is not in line with the external clock. Your sleep drive is still building up as usual, and it kind of can throw off your feeling of alertness and your sleep during that time while you're still adjusting. And then the final thing that I want to talk about, just as basics around sleep, but it's also really important when we think about how what our expectation should be about sleep is that sleep really changes as we age. Of course, if we think about toddlers, infants, they need much more sleep. As we get into adolescence, there's this tendency to have what's called a delayed sleep type, where our teens want to go to bed later, they want to get up later, and that is driven by kind of a change in their internal clock, their preference for later times. Which is where lots of talk around changing school start times for secondary school comes from because of this, this fact that it's creating a sleep deprivation for those teens. But it also changes as we age throughout the life course. So as you can see here on again, this is the y-axis, this is minutes. And then on the bottom here on the x-axis is decades. And so the take home here is, if you look on this line of where the REM is, this line, this area under here, it's about the minutes of sleep that someone gets, and it's like by stage. And so what you can see here is that as we get older, we just get less sleep. And this is particularly true when we get up to 65 and older. We're still trying to understand why this occurs. We can see in this graph that it seems to be related to kind of what's called WASO, or the wake after sleep onset, and that increases. So that's the number of minutes that someone wakes up in the middle of the night. And so some of this, as we age, is due to having to use the bathroom more, but people are kind of awake more in the middle of the night. There's also this decrease in slow wave sleep, but again, it's not clear if that means that's normative, and that's just part of how the brain ages, because sleep lives in the brain, or is it that older adults are not getting the sleep that they need and there's a need for intervention? And so that's kind of an open question at present.